All right, I'm going to talk about circles here. I want to cover four things. I'm going to cover the center point of a circle, which is a point that is the same distance from any other point on the outer edge of the circle. That outer edge of the circle is called the circumference. Okay, and if I wanted to draw a line from the circumference, any point on the circumference, to the center point of the circle, that is going to give me the radius. The radius. Okay, and if I extend that point in a straight line to another point on the circumference, say that's a straight line, 180 degrees, make it look a little better, 180 degrees. Okay, I have two radii. Well, if I take at one point on a circle and another point on a circle that passes through the center point, it's the same thing as that. It's two radii, but it's also one diameter. All right, so you can say that two radii is equal to one diameter. All right, so if you have the length of the radius, you double it, you get the diameter. If you have the length of the diameter, you divide it by 2 and you'll get the radius. Okay? There's also a pretty interesting relationship between a circle's circumference and its diameter. Okay, a ratio of the circumference to the diameter. Okay, remember that circumference was the outside perimeter, and the diameter is the point on a line connecting 2 points on the circumference and the center point. So 3 points to make a diameter. All right, so if I have something like this, okay, let me zoom in here. Okay, I'm going to make a point on this line here, and I'm going to mark that point like that. Okay, and then I'm going to let this thing roll for 1 revolution. Okay, so let's see how smooth I can get it to roll. Okay, there's 1 roll of the revolution. Okay, and that would represent 1 circumference. That is the length from here on this circle. So this circle here, that is the length of this circle. That goes up from here all the way around to there. Okay, that is the length of that circle there. Okay, the diameter I can measure like pretty easily, like this. Okay, I'm going to take a ruler, or my protractor here, and I'm going to put the point on one of the circumference, and I'm going to rotate it until I see the maximum reading that I can get, and that maximum reading looks like about 1.7. Okay, and that's the diameter. All right, the diameter was approximately 1.7, and let's measure the circumference. The circumference from center to center is about, we'll say 1.4. Okay, circumference is approximately 5.4. It was 5.4, right? Double check that. Yeah, 5.4. Right, so the ratio of the diameter diameter was like 1.7. Okay, that's the diameter, and the circumference on my circle was 5.4 to 1.7. Right, that is my circumference to diameter ratio. Okay, if I put that in the calculator and I go like 5.4 divided by 1.7, I get like 3.17. Okay, that's measuring it, 3.18 maybe. Okay, that's measuring it with, you know, some pretty rudimentary methods, right? But if I were to get a really precise measurement, like maybe some calipers, right, I would have gotten about 3.141592654, and it would continue on for infinity. That's a really bad infinity. Okay, that number should look familiar because that number is represented by the Greek letter pi, 3.141592654. So any circle circumference to its diameter, circumference divided by diameter, equals pi, right? So I can measure anything that has a circle. I can measure this, and the diameter of this is, let's see, this thing is, diameter is 4.7. Okay, that thing is 4.7 is the diameter. Okay, so if I want to find the circumference, well, I know that the circumference is bigger, the circumference is greater than the diameter by about 3.14. Okay, so I have the diameter, I multiply it by 3.14. Diameter is 4.7, multiply it by pi, and I get the diameter is approximately 114.765, right, centimeters. Okay, and conversely, if I knew that my circumference of something was, we'll say, 12 centimeters, I would divide it by pi, and I would get the diameter. So 12 divided by pi, and I would get approximately 3.8, right? So that is the relationship between pi, the circumference, and the diameter. So you can say, erase all this stuff, you can say that pi equals a circle circumference divided by diameter. Okay, so if you're going to solve for the circumference, you multiply both sides by d. That's going to cancel out the diameter, so you get the circumference equals the diameter times pi, which is what I just showed you. Okay, and you also remember that the diameter is how many radii? It's 2 radii, right? So the circumference equals 2, the pi in the middle there, pi times radius. Okay, so these are the two, that is the derivation of that equation, right? Circumference equals 2 pi r, or the circumference equals pi times the diameter, or radius equals circumference divided by 2 pi, or the diameter equals the circumference divided by pi. Right, so that's all the different rearrangements of that equation. Okay, next we're going to get into the protractor.